In the world of temperature gauging, the dial thermometer is a lot easier to read than a glass stem thermometer. A needle points to bold numbers on a dial, and even from a distance, it only takes a quick glance to confirm an initial impression that things are heating up. All the highs and lows are plain to see on the face of a dial thermometer. It often comes with lengthy tubing to measure temperature from afar. It's a handy feature for power plants and heating and refrigeration systems. To begin, rollers straighten very narrow metal tubing. Then a blade cuts it to length, depending on the application. As the blade makes the cut, a mechanism pries open the ends. Next, a worker inserts a fitting into a much wider tube that will become the thermometer sensor bulb. He secures the tube in a fixture and welds the narrow tubing machined earlier to the fitting on the end of the bulb. With the bulb and tubing now linked, production moves to the next stage, the making of the burden tube, which is a kind of spring. A worker cuts flat, wafer-thin tubing to length. Down the line, they clamp the flat tubes in a device that's on a track. It moves past an arc welder that melts and closes one end of the flat tubes. Here's a before and after comparison. A worker now encloses the tube in a die and drives a pin into its open end. This widens and redefines the opening from inside and outside. He slides it over another pin and activates a mechanical punch press. This fine-tunes the shape and dimensions of the opening. The next worker clamps the tube in another device. He operates a roller to wrap it around a mandrel, bending it into a C shape. This completes the thermometer's burden tube spring. The next worker clamps a bracket to the bottom of the burden tube. He inserts a small piece of connector tubing in the burden tube hole and applies liberal amounts of a flux compound. The flux prevents tarnishing of the metal as he melts silver solder to braze the parts together and to seal the opening. Now a test. He pumps gas into several burden tubes and immerses them in water. If no gas bubbles out of the tubes, it means the tubes are perfectly sealed. The gas pressure also causes the tubes to spring into action. It's this action that will move the pointer on the dial of the thermometer. The next worker attaches a brass connector to the tubing. He brazes them together to create a solid bond. He folds the brazed parts into the curve of the burden tube and pushes it into place with a mechanical press. He installs the gear assembly that will translate the linear movement of the burden tube into the rotational movement of the thermometer pointer. He screws the dual temperature dial to the burden tube assembly. The more detailed and extensive the scale, the bigger the dial. This one is mid-sized. And now everything comes together as he tethers the sensing bulb along with a short fill tube to the back of the burden tube assembly. Using a brazing torch and solder, he seals the connection. He then steam cleans the brazed joint. He buries the bulb in a hot sand bath, which causes any moisture in it to evaporate. Through the fill tube, he fills the bulb with nitrogen gas. To calibrate the thermometer, he plunges the sensing bulb into boiling water and adjusts the pressure of the nitrogen gas until the dial reads 100 degrees Celsius. The fill tube's job is now done, so he crimps it to seal it off. He tests its accuracy by immersing the sensing bulb in numerous controlled baths, each one a different temperature. And if it's on the mark, he encloses the inner workings in the stainless steel case. He protects the joint with a special metal spring and snaps a clear window to the case. A gasket between them ensures a dust-proof seal. He screws a part called a well to the sensing bulb connector. The well will protect it in high-pressure situations. This dial thermometer is now ready for the ups and downs of temperature gauging.